Hello everyone. Good morning, good afternoon, and good evening, depending on where you are in the world. My name is John Vincenzo, and on behalf of Silver Peak, I'd like to welcome you to today's webinar titled Evolve Your WAN with Broadband. Just a couple of quick housekeeping items before we get started. At the bottom of your screen, you will see some widgets that you can use to interact with us. The Q&A widget allows you to submit questions at any time throughout the webinar, and we will address questions at the end of the event. You can also find a copy of today's slides in the Resources widget. With that, let's get started. I'd like to introduce you to our speakers today, Ethan Banks, networking expert and co-founder of Packet Pushers, and David Hughes, founder and CEO at Silver Peak, who will cover the state of the WAN today, what SD-WAN really means, and how to gain more visibility, flexibility, and control while dramatically lowering your networking costs. With that, let's get started. Ethan?
Hi everyone, my name is Ethan Banks. You may know me from the Packet Pushers podcast. Just to introduce myself a little bit more, I am a CCIE 20655 with an expertise in routing and switching, a network architect. I do quite a bit of writing and podcasting these days. I've been in IT as a network architect or engineer of some sort since 1995. I do some writing for Network World, Network Computing, and other places online. If you've been to Interop in North America, either the New York or Las Vegas shows, you may have heard me speak there. And I'm also available for consulting these days. If you're up in the Boston area, you could get a hold of me and maybe we could do something together. What we want to do in the first part of this webinar here is talk a bit about software-defined WAN, kind of from an educational perspective. What is this technology all about? And so I'm going to take you through 4 parts here to get us accomplishing that part. So we'll talk about the state of the WAN, what's really going on in our wide area networks these days, what SD-WAN is not, what SD-WAN actually is by taking a look at the architecture, and then how you would get started with it. So the state of the WAN, let's level set here. Let's talk about what our wide area networks look like. And I would describe the typical enterprise WAN as this. It is complexity born of necessity. I've administrated a bunch of WANs over the years, and what I've found is you kind of end up with this interesting hodgepodge of connections that are driven by what's available to you, how much the connection cost, your security requirements, what service level you need to get out of the thing, and then how redundant and resilient you need it to be. And so by availability, I mean sometimes you're constrained by just what your options are. Whatever the carrier can sell you at a given location is what you're able to go ahead and buy. And sometimes you don't always get exactly what you want. You get what you can. Cost. Naturally, a carrier would be delighted to build you anything you want as long as you're willing to pay for the infrastructure build-out, which isn't realistic for many of us. So a lot of times you go with what you can actually afford, which is probably, in some cases in rural locations, let's say 2 or 4 wire TDM circuit, and that's what you get because it's what you can afford. Security, of course, is a big driver. What's safe? What's compliant for a given set of data I'm pushing across my wide area network? Service levels. If you're connecting a remote office to a head office and you need to carry voice traffic, let's say, you need a circuit that you can be confident in that it's going to carry that voice traffic reliably. Meaning it's probably some kind of a private carrier circuit that honors QoS and DSCP tags, and therefore you will pay for that to get that sort of reliable service level performance out of a given circuit. And then resilience. A lot of WAN designs are driven by the need to keep a remote office connected to a headquarters office no matter, and so you end up with 2 or more circuits. And then some kind of a routing scheme to fail over between the 2 of them, and so on. And depending on what you're using as a transport, you end up with a lot of additional complexity layers on top of that, which we'll talk more about as we go on here. And so if that's our typical enterprise WAN scenario, you end up with something that looks like this. You got a lot of routers, you got a lot of circuits, you got a lot of different access methods, and it's a bit of a complex infrastructure. So if you look at our colorful diagram here, we've got a couple of headquarters sites, we've got 8 different branch sites, and they're all mapped into a variety of different clouds in the middle, different private carrier clouds, different public internet providers, Oh, and then by the way, let's not forget about that yellow cloud at the bottom that shows us public cloud and SaaS, because if your company's like a lot of other ones, then that means they took something like CRM and they moved it into the cloud as Salesforce.com, or there's certain workloads that got spun up on Amazon Web Services, let's say. And so now you've got this additional problem of the private WAN and public WAN combination that you own for connectivity between all your offices, and then this piece of connectivity going into some public infrastructure, and you don't own that piece. It leaves, it hits the edge of your network and then goes off into transport you don't own. But you're expected to manage that somehow as well and make sure performance into public cloud works outside of your border as well as the traffic that is inside your border. So there's a lot here. There's a lot of pieces and parts here. And this is a simplistic diagram, and those of you with really large WANs, I'm sure this looks sort of familiar, only more so. More carriers and more branches and so on. So if you've got this sort of a world, what is your day-to-day environment like? What are your challenges that you deal with in this WAN? And I, again, based on my own experience, I'd summarize it this way. You got a lot of money tied up, it's expensive to run, and it's just a variety of different complexities and challenges in operating it. So just going from top left, and then we'll go around the circle here on this slide, expense is kind of a huge one. Even though if you're an engineer, you don't think much about the cost, you can't not be at least somewhat aware of just how expensive operating a private wide area network is. It's probably one of the biggest IT budget line items that there is. Really pricey, because private networks with guaranteed service levels just cost money. They're going to charge you dearly for it and probably lock you into a long-term contract. And so a lot of businesses are focused on trying to get that cost down. I mean, and some of that you've probably been a part of. Hey, is circuit XYZ still up? I thought we disconnected that 3 months ago. Why are we still getting billed for it? Those sorts of wonderful questions you get to dig into to try to keep your expenses under control. Routing across your wide area network is another challenge here. And we're going to talk more about this in a bit, but just to introduce the idea, routing across a wide area network is a function of best path. If you're a network engineer familiar with OSPF or EIGRP or BGP, you've got some sense of how those protocols compute a best path across the network. And again, we'll talk about this more in a bit, but just to throw the idea out here, it's really a one-size-fits-all solution, and the considerations traditional routing protocols use to come up with their metrics and make a forwarding decision, they're pretty basic, pretty rudimentary stuff, and you've got no differentiation of applications that come in there. It's everything or nothing for a given destination and a path that gets computed. Security, of course, is another concern if you're using public transport to get traffic between remote offices. Then you're dealing, at the very least, with encryption on some level. And that could be application-level encryption, but it probably also means IPsec encryption, depending on the nature of the data that you're carrying around. And that's complex. Again, someone who's dealt with that before, you start dealing with a mesh of IPsec tunnels and dealing with key management and so on. There's a lot of headaches there. Now, if you're going to add stateful firewalls into the mix, now you've got that concern as well, managing those firewalls and that firewall policy, etc. And then if you're trying to virtualize your wide area network, where you've got multiple networks layered on top of your wide area network infrastructure, now you've added just another layer of security and complexity to separate that traffic out into VRFs and manage that infrastructure. And then last here, as we complete the circle, quality of service. Boy, I built a lot of big quality of service policies and deployed them out over some sizable WANs. And it ends up that your QoS policies that you build are kind of a one-size-fits-all solution that you base on peak application loads. You do a traffic analysis, figure out what the mix of traffic is over a given pipe, look at the congestion times, and then build a policy that's going to allow traffic to flow during that worst-case scenario peak load time, and hope it's good enough and hope that it works out. And QoS policies are okay as far as they go, and you can, the more you study it, the better you get at tweaking your policy to make it work well. But no matter how good you get at writing that policy, it's still a compromise. That QoS policy is never going to react to network conditions and give you a policy that is optimized for the real-time state of the network. It's something that you can't, as an operator, tweak all the time, so you just do the best you can with what you've got. Okay, so with that as a backdrop, now let's move into software-defined WAN. And let's start here by saying what software-defined WAN is not. And I raise this as an issue because software-defined anything is such a huge buzzword in the industry right now. There's just a massive amount of product names and marketecture and what I call marketecture and some whiteboard engineering and then slideware built around software-defined something or another. And it doesn't really amount to a whole lot when you dig down under the hood and see what's going on there. But SD-WAN is not that. SD-WAN is, in fact, real technology. I've listened to lots of presentations and studied a lot of the products that are in this space now, and this is technology that exists. It's not a unicorn. This is real, honest-to-goodness technology that you can buy today and so on. And I would even go so far as to say SD-WAN is one of a handful of mass-market ready software-defined networking applications. There's a lot of SD stuff out there that if you were to actually get your hands on it, what you really got is an idea and some code, and it's kind of unfinished, and you need to put a lot of work and effort in to make it do something useful in your network. Software-defined WAN is not that. These are products that have a lot of polish on them, and they are here to deliver a very specific set of features and functionality for you. Okay, so it's real. Then great. What is it? Let's start getting into the nuts and bolts of what this actually is. Let's break it up into its component parts here. If you're a network architect, you're familiar with what your wide area network looks like. I thought we would take a minute to talk about the major elements that comprise an SD-WAN architecture and then map them back to WAN architecture that you're familiar with from a traditional environment. And I've identified 5 of them here. And let's start from left to right on this slide. The first would be policy. So in a software-defined WAN architecture, you've got a policy. And what does this policy do? It is a policy that defines how flows are to be forwarded. And if you want to map this to something you know, think about it like the command line interface. Only in software-defined WAN, you've got a policy that you're defining centrally. We'll talk about that more as we go on. And you're writing a policy in kind of typically a plain-spoken, business-oriented language where you're not having to get into a bunch of IP addresses and nuance necessarily. You can say at a much higher level that you want a particular class of application to be forwarded across the wide area network with a specific kind of treatment. And this policy idea is central to what software-defined WAN is. And you'll see how it fits in as we move through these other elements here. And so let's go on to the next one, which is the controller. In a software-defined WAN architecture, you've got policy, and then you've got a controller. The controller is the central device, central piece of software that is distributing policy to forwarders. So if you want to compare it to something you know, think of the controller as the control plane. So if you're a network engineer who knows the control plane to be something like the routing protocol, that thing that influences how the router forwards traffic, the controller is taking that role on from a central perspective. He is pushing the policy that you've created down into all of the forwarders. And again, that is your control plane. All right, then, well, then what's a forwarder? So we got a policy, we got a controller. What are these forwarders? Well, the forwarder is roughly like a WAN router. It is a commercial, off-the-shelf, x86 device with gigabit interfaces on it that are going to push traffic in accordance with the policy. So the forwarders are, again, roughly like your WAN routers. You're going to have a forwarder at a headquarters device and a forwarder at each of your branch offices. And these are the guys that are going to actually push traffic across your software-defined architecture. How do they know how to do it? They get a policy from the controller. Where did the controller get the policy? You wrote it. Now, to be clear, a forwarder is not a one-for-one replacement of a WAN router necessarily. A WAN router can do things like terminate a TDM circuit, like a T1 or an E1, or an LTE circuit that a x86 box with gigabit Ethernet interfaces on it can't actually do. So it's not, it doesn't do all the same things that a WAN router does, etc. But if you're trying to position all these parts into an architecture you're familiar with, that's the closest thing it maps to, is the WAN router. Okay, so another key piece here then is analytics. One of the things that software-defined WAN is really good at is understanding the traffic that is flowing through it. And so one of the benefits you get out of your software-defined WAN is a rich set of reporting and analytics about how the WAN is being used, what applications are using the WAN, whether or not you are compliant with security requirements, etc. And again, this would be roughly like your network management system. If your NMS does things like SNMP monitoring, or maybe it can do net flow analysis because it can take flow records off of devices and then compile those into statistics for you. This would be roughly like that. You just getting analytics as a part of your SD-WAN package, a very rich set of capabilities there. And then the last piece of SD-WAN architecture that I want to bring out is paths. Now, this would be the physical paths across which your SD-WAN forwarders can choose to forward traffic across. And this is key because a lot of times we think in very almost a binary fashion about our WAN paths. We've got a private path, we've got a public path, and that's it. And if we're really crazy, maybe we've got 2 private paths because, gosh, our network's just that important to us. But here with software-defined WAN, you can add public internet links into the mix, and a whole bunch of them if you want, and the more the better. So really you end up with a hybrid WAN infrastructure that you are mapping your software-defined architecture to, and the more paths you've got to choose from, the more capable the forwarders are, or the more likely the forwarders are to have a path available to them that's going to meet the SLA requirements you've baked in to your policy. Okay, so those are our building blocks here. Let's think about let's consider our thinking process with those building blocks. How are you actually going to push traffic through this infrastructure? And some of this may be apparent to you just based on the last slide, but let's walk through this. Let's say your SD-WAN architecture is out there, it's been deployed. What's actually going on here? I mean, the first step is the creation of policy. You as an operator or an engineer would create this policy, and that policy is going to describe quality of service, security, etc., in the context of specific applications. Hey, when this application is going from here to there, it's my financials application. I need it to have these sorts of characteristics. It's got to be low latency, or maybe it's a voice application. It's got to have low jitter, and so on. Or maybe it's just plain old FTP traffic. I don't care how, as long as it gets there, that's good enough for me. It can be bulk, best effort kind of traffic, as long as there's enough that we can make the transfer. So you build a policy, again, that is application oriented, and then that policy lives on the controller. And then if we go to the next step here, from once we create the policy, we're going to distribute that policy that's been created from the controller out to all of the forwarders. Again, the forwarders being more or less like your WAN router. You don't configure as an operator and engineer your individual forwarders. That is managed by the controller, pushing that centralized policy down into the forwarders for you. That policy gets distributed in that way without you having to touch the forwarders themselves. We'll talk more about the forwarders themselves and how you get them online in a bit. And then you are now in a position where you can forward flows. So we're creating policy, we're distributing that policy, and now we're forwarding flows. Application flows are forwarded according to policy. Again, this is not simply IP packet forwarding, right? if you're a network engineer very used to show IP route and you look at your routing table, everything is oriented around some destination network that you're sending traffic to. This is not simply that. This is actually application-oriented, where traffic, depending on the application, may take different paths through the network based on the SLA that you've defined in your policy. Another point to bring out here about forwarding flows is that SD-WANs typically operate as an overlay, and so your traffic is secured via an encryption scheme and then sent across the wire as an overlay across that physical IP WAN fabric that you've created. And so this would be like an IPsec tunnel is exactly what this is. DMVPN, if you've done that, it's similar to that kind of an idea. It's a tunneling methodology. Don't be scared by the word overlay if you've not run into it before. That's all it is. We're just talking about tunneling. So we create policy, we distribute it. Now we're forwarding flows in accordance with that policy, and we're also going to be, the last box there, analyzing the network as traffic is flowing between forwarders. Paths between those forwarders are constantly being analyzed to see which is the best path. So 1 minute this path might be great and you can send traffic down it because it's got good quality and low jitter and so on, and then there could be a problem on that link, a brownout. It's all of a sudden become a little lossy, whatever's going on, and so the forwarder can detect that in real time and swing traffic over to a different path that is going to allow traffic to be to meet the SLA that you set up in the policy. So okay, if that's our process here, that's kind of our thinking process. I want to highlight one element of this here, which is best path. Again, we think about finding best path for a routing domain. Traditionally we think of things like hop counts. We think of things like bandwidth and delay, or we think about link cost. And you routing protocols take all these into consideration. They come up with a metric that is one size fits all per IP destination, and it can't differentiate between packets and flows. It doesn't know the difference between voice traffic going between a particular destination set and web traffic, or it has no sense of that. And so, and also you don't have real-time link quality being built into a traditional metric calculation. It doesn't know what the load is on a link at any given time, or the fact that the link is experiencing 5% loss for whatever reason. SD-WAN does know all of those things. It computes per flow or per application in accordance with policy. And the best path for one application might be different than the best path for another one. And that could be true even if the physical topology and the links are all up and everything remains exactly the same. SD-WAN knows the difference. Okay, another point I want to bring out here is that you can integrate SD-WAN without tearing out your existing infrastructure. This is not a rip and replace sort of a technology. Or if you read my writing, you hear me talk about displacement technologies. SD-WAN is not, by default, a displacement technology. So let's take an example here. If you look at this diagram, I've got a couple of sites that are communicating with each other. The purple circles there, Site 1 and Site 2. And we've deployed some SD-WAN forwarders, and let's also assume controller policy and all that's in place. The SD-WAN forwarders communicate to each other via tunneling. There's an overlay going between them. Well, how does the SD-WAN forwarder get traffic to the other SD-WAN forwarder? It's got a couple of choices. It can go up high through the blue boxes, a public path internet circuit of some kind, or it can go through the yellow path, a private path WAN router, let's say. It can go either way, and it can monitor the links to know which is better at any given point in time. And you're going to say, oh, it's always going to pick private path because that's always better. Not really. If you actually get into monitoring the quality of public path internet, it's actually quite good and suitable much of the time to carry even sensitive traffic like voice that can get fussy about things. Because this is an overlay going between the SD-WAN forwarder, you don't know or care which path is being taken for the traffic to be delivered between the SD-WAN forwarders. It could go private path, it could go public path. Not your concern. The overlay masks that, abstracts that away for you. And that also has the benefit of you don't have to rip out your existing routers. It's an overlay on top of those. So you might even need those routers if you're terminating circuits that are not straight up Ethernet. So if you had a straight up Ethernet circuit, you could terminate it on the forwarder if you want, but you don't need to day one. You certainly don't need to. You might eventually, but you don't have to get started at all. You can just add this to your existing WAN infrastructure. All right, so as we move along here, let's talk through getting started with software-defined WAN. What does this actually look like? And I've identified 4 pieces here that are what you're going to do. And some of this is a repeat of what we talked about. We'll just go through it quickly, but just to try to bring all this together, if you were to put SD-WAN onto your network and add this to your WAN infrastructure, what's actually happening? What's going on? And we've got 4 things here I've identified. Zero-touch provisioning, service insertion, policy creation, then analytics, and reporting are all part of the real-world aspects of deploying software-defined WAN. One thing that we haven't really talked about yet is this zero-touch provisioning. And this is the idea, and this goes back to something I was talking about earlier, where you don't have to get a software-defined WAN forwarder working. You don't have to individually configure it and then ship it and then hope it comes online. Rather, it's a phone home model where you plug the forwarder in, he gets a DHCP address, he knows how to contact the central controller that's already been pre-configured from the factory, and he comes on the line, talks to the controller, and then he is able to download a policy from the controller so that he's in a situation where he's provisioned. He's ready now to start forwarding traffic. Again, you don't have to do this individually. Okay, so now that remote forwarder, zero-touch provisioning, he's phoned home, he's got his policy, now you want to put him in the traffic flow. You want to do service insertion here. And then I guess there's a couple of scenarios that to consider when you're thinking about service insertion. You've got branch consideration, and then you've got head-end service insertion as well. From the branch side, you're probably going to deploy this device inline. This is straightforward. It's the most simple way to make this deployment happen. If you've got no IT staff at the remote site, it's going to be the easiest thing. Hey, I've got this port, take this cable, plug it in, off you go. Now you've got this device that's been plugged in between your remote office switch and your remote office WAN router. The SD-WAN router is now inserted in the middle there in the traffic stream. There's other options, but that's the most common deployment. If you've done, say, a WAN optimization deployment at some time, you've probably done a scenario like this. Now, your head-end site, you're going to want more flexibility, right? You're not necessarily going to be comfortable to just drop your software-defined WAN forwarder at your head-end sites right into the middle of all of your WAN traffic. So if you want to piecemeal this, you absolutely can. You can plug it in off to the side and then use a redirection technique like WCCP, Web Cache Control Protocol, or policy-based routing, PBR, to direct selected traffic streams to the head-end branch software-defined WAN forwarder. And this is a good time to mention, actually, that the software-defined WAN controller, which I mentioned earlier as one of the key elements of a software-defined WAN architecture, the controller is never in the data path. So if you've been studying software-defined architectures and know that in certain scenarios the controller kind of has to answer questions before a packet can be forwarded, that is not true in a software-defined WAN scenario. In an SD-WAN scenario, the controller is never in the data path. And if you think about it, it kind of has to be that way, right? Whereas in a data center, you can more or less assume that the controller and, let's say, OpenFlow switches are always going to be able to communicate. You can't make that assumption in a WAN. The likelihood is, at some point in that WAN's life, a remote office is going to be completely isolated from the controller just because of the nature of wide area networking. There's a lot of geography, there's a lot of miles, there's a lot more chances for things to cause a network fracture, and so it's important to understand that the controller is never in the data path. The worst case scenario would be a forwarder loses touch with the controller. He can still forward in accordance with the policy he's got, but he may end up with a slightly older policy until he's finally able to communicate with the controller again and get an updated policy. Speaking of policy, again, to reiterate a point I mentioned earlier, you're going to get that forwarder out there. You're going to insert that forwarder into service on both the branch and remote sides, and now you've got this policy that you've created that's going to be a part of your forwarding decision now. We talked a lot about this, so I'm not going to park here anymore. And let's move on to our last point, which is analytics and reporting. So again, if this is life within a software-defined WAN architecture. You've got these forwarders who are doing rich data analysis, and then that data can be analyzed centrally. And this is important to bring up again because this is application flow-based forwarding in a software-defined WAN architecture, not simply IP routing. So you actually have to know as a forwarder what the application is that's going across you, be able to identify it, match it to the policy, and then forward it accordingly. Since you have to be able to do that, it kind of makes sense that you'd also be able to gather a lot of analysis and statistics about what's going on and then have that presented to you. So you, as a network operator of a software-defined WAN environment, have the ability now to look at a bunch of information about what's really going across your WAN, and get a lot of complex reporting about it. So think about that scenario where the auditor guy just showed up to make sure you're, I don't know, PCI DSS compliant. And typically you've got to do what? Generate reams of paper of individual device configurations and so on. You would not have to do that in a software-defined WAN environment. You would be providing compliance reports that come off of the central controller that can describe how traffic flows through your environment, the security parameters that it is subject to, etc., and demonstrate compliance in that way. Okay, so that ends my section of this presentation. That is a kind of an educational backdrop of software-defined WAN, the thinking process and how it works. And with that, I'm going to turn this over to David Hughes, who's going to continue on the specifics of the Silver Peak solution, with me jumping in with a question every now and again if something comes to mind.
Great. This is David here. Thank you so much, Ethan. I think that was a really great overview. So for the WAN, when you kind of step back, what's a WAN for? A WAN is for connecting users to their applications. And over the years, the WAN has evolved. So if you go back a couple of decades, it was private lines. And then in the early 90s, we moved to frame relay, which made it easier to build hub and spoke networks. And then around about the year 2000, people migrated from frame relay to MPLS. And that was largely driven because people wanted to have an easier way of building mesh connectivity rather than hub and spoke connectivity. And that in turn was driven by people beginning to roll out voice over IP and beginning to do video conferencing. And so in the past, it's been changes in the apps that are being used and the way that users connect to their apps that have driven changes in the wide area network. If we kind of come to today, most companies are using the MPLS technology to build their wide area networks. And there are many good things about it. You get SLAs. It's a known technology. It's understood. It's available for many different providers. The challenges arise really because the apps that the users are connecting to are moving. So 5 or 10 years ago, when MPLS was clearly the best choice, the applications typically resided in the data center. So your Siebel or Oracle in the data center, your users in the branch. The main traffic flow was branch to data center. Today, more and more, and in many cases, most of the traffic, most of the applications are residing on the Internet, either as a cloud service, SaaS service like Salesforce or Office 365, or they're running in a IaaS service like Amazon AWS. Either way, the traffic pattern is now from the user in the branch to the application in the cloud on the Internet. And typically, the way most companies do this today is that traffic, when you're in the branch, it's taken over the MPLS network to a data center or a headquarters site, and then brought through a firewall out onto the Internet, and then to the SaaS service and back again. The challenge with this approach is that it's driving all that internet traffic across your MPLS network, and that is more expensive than internet bandwidth, and the path that it can take can be less than ideal. For instance, if I'm at home here in San Francisco, I might be connected by 100 megabit broadband internet, and if I access Office 365 in Seattle, I'm going over that 100 megabit line, I'm going straight up to Seattle, a pretty direct route. If, for instance, I was in a branch just down the road, and I was working for a company headquartered in New Jersey, I might be connected by 10 megabit MPLS. So I'm going on 10 megabit MPLS all the way to New Jersey, then going through a firewall, then back to Seattle to Office 365, then back to New Jersey, then back to San Francisco. And so this routing is a problem. It's obviously less direct, and there's a big difference in the bandwidth that I can afford for broadband at home versus what we're using for MPLS in the branch. And so this state of affairs is driving people to rethink things. And there's obviously a lot of different approaches. You can do things like try to add more egress points from your MPLS network. But ultimately, there's a huge change going on in the traffic patterns, users to the apps, moving from the data center to the cloud. And so we believe it's time for people to reevaluate the way that they build their wide area networks. Now, at first blush, it seems obvious that if I'm accessing a SaaS service, why not just use the internet? If I can use it from home, why can't we do it just that way in the office? The challenge with that is, and there's kind of three buckets here, the challenges that people see are first, performance and reliability. How are you going to guarantee delivery of data? With MPLS, you get an SLA, so there's 99.99% uptime or whatever it is your guarantee is. And if things aren't working, you know there's someone on the hook. Even if they can't fix it straight away, they are working to get that resolved as quickly as possible. If you're building your own WAN over the internet, you're going to have to deal with blackouts and brownouts and packet loss and packet reordering. And so that makes people pause and think, okay, I'm not so sure that the internet's right for me. The second thing that we see giving people pause is security. So in the simple scenario we talked about with an MPLS backhaul to, say, a couple of firewalls, there are only two big entry points in and out of the network. And so from a security point of view, things are somewhat simplified. We hear customers are concerned that as they blend their WAN with the internet to take advantage of broadband capacity, that they're worried that somehow this will introduce new vulnerabilities and make their network harder to secure. And even if it is more secure, that it will be more complex to manage. Then finally, the last set of concerns is around visibility and control. And we talk about traffic going to the internet as if it's all one thing. And for most people, it's not. You can divide it up into at least three categories. So the first category is traffic that's going to a SaaS service that the business knows and trusts, like Salesforce or Office 365 or Workday. The second category is traffic that's going to, say, Yahoo Mail or Facebook or YouTube, which are known applications, but they're probably users doing a little bit of home from work instead of work from home. Not something you necessarily want to encourage, but it's not necessarily a problem. And then the third category of traffic going to the internet is everything else. So traffic to unknown sites, traffic to countries in which you don't have business, basically stuff that needs to be looked at more carefully. And so what we hear from people is if they want to use the internet and they want to more effectively route their internet distant traffic, they at the very least need to be able to categorize the traffic into these three categories, or in most cases even finer granularity. So they really need visibility and control that's missing today. So what we've done at Silver Peak is ask ourselves the what if of what if we could solve these problems? What if we could let you use the internet to either augment or replace your MPLS network and take advantage of the big bandwidth savings that come with broadband internet? And in many cases, we're seeing savings of up to 90%. The second kind of part of the what if is what if we could do all this without impacting performance, where you could use either 2 or more broadband links to deliver private line-like performance over the Internet. What if you could address these security, visibility, and control concerns? And so we've just last week announced a new product family called Edge Connect, which is designed to address these, this kind of what if, to address these issues. It is an SD-WAN solution, and Ethan's done a great job of describing in generic terms what an SD-WAN is. And with Edge Connect, you can build an SD-WAN. There are 3 components in what we've announced. The first is the Edge Connect devices themselves. That corresponds to what Ethan was calling a forwarder. So the Edge Connect comes in physical and virtual form factors. You take this device, you plug it in a branch. Basically, you need to add power. You need to plug in a WAN port, and you need to plug in your LAN side, and you're up and running. The device phones home. It will appear as a newly discovered branch in your orchestrator. The orchestrator is the second piece of the solution. It's like the controller in Ethan's description. So the orchestrator gives you visibility into your whole network. It also lets you apply business intent policies. So for instance, in this new branch coming up case, we see there's been a new branch added in San Diego. We're asked, do we want to accept that branch onto the fabric? If we say yes, as soon as we click yes, the policies that we have defined will be downloaded onto that Edge Connect device, and we'll be up and running in this branch in minutes. The third piece of the solution is what we call Unity Boost. And what we have here is the ability to deploy application acceleration technology on demand when and where you need it. So you can kind of think of this as part of addressing the performance concerns that people have about using the Internet. What we've done is create 2 tiers. In the first tier, which is the base part of Edge Connect, we address the packet loss, and we have multipathing and things that gets you the basic level of connectivity that you need to get an SD-WAN up and running. Inevitably, there'll be some locations and some applications where, because of latency and distance, you need application acceleration to get those applications performing as well as they should. And so you can buy Unity Boost by the megabit per second, apply it by app, by site, or by time of day, whatever way you want. It's very flexible pricing to address those application performance concerns.
David, the Unity Orchestrator, does that live in the cloud, or is that something that lives in my data center?
That's typically deployed in your data center. It's a virtual machine, so virtual appliance, and you would typically deploy that in the data center, although you can also deploy that in the cloud if you would want to.
Got it.
The Edge Connects work in the broader Unity architecture that Silver Peak has. So Unity, if you like, is the name that we have for our SD-WAN fabric. As you can see in the graphic, Unity is an overlay, and it's an overlay that connects your physical locations, your branches, your data center, with also your virtual locations, so the SaaS services that you're using and the IaaS services you're using, like Azure or AWS or VMware vCloud Air. It allows you to leverage broadband to quickly build an overlay that kind of mixes and matches MPLS with, say, cable, with DSL, with LTE. You can choose whatever underlying technology you want. It lets you do zero-touch provisioning. So as Ethan talked about, when that device plugs in, it phones home, and you're up and running with really very little expertise needed in the branch. And so that's an important piece in SD-WAN. The idea is to make it really easy to deploy 4 branches, but make it just as easy to deploy 40 or 400 or even 4,000 branches. The other piece that makes that kind of scaling easy is what we call business intent policy automation. So typically, in fact, pretty much exclusively for the last couple of decades, networks are configured device by device. And so everything is about configuring this element, then that element, then another element. And in some cases, you can apply templates to many elements at once. But even in that case, the things you're configuring are actually per element information. And if you deploy 10 branches today, use a template, and in a month you use a slightly different template, you end up with all your branches having slightly different configurations, like snowflakes. With SD-WAN and with our Unity Orchestrator, we overcome that problem by introducing a level of abstraction that lets you define what you want to do in terms of the business problem. So you might say, I want to build a voice overlay. I want my voice overlay to be mesh connected, so every branch can talk to every branch. I want this voice overlay to be optimizing for the lowest latency and lowest jitter paths, so I want to maximize quality. Then I might want to build a different overlay. I might want to build a replication overlay. I want my replication overlay to be hub and spoke to the hubs where where I have the core of my replication. Then I want to maximize throughput rather than maximizing quality. And in this way, you can describe your network as a series of overlays. And in the Unity Orchestrator, you can describe that overlay in just a single form. And so it really lets you simplify deployment and lets you make sure that your network remains in a consistent state all the time, rather than having to worry about how individual elements are deployed. So, drilling down one step in terms of what are some of the key features of EdgeConnect. The first is dynamic path control. This is the ability to dynamically select the best path for a particular kind of traffic. So in the example of the voice traffic, where we say looking for the lowest latency or lowest jitter, we're continually measuring on each path which is the lowest latency and which has got the lowest jitter, and choosing that path for the voice traffic. If things change, we'll move the traffic, and we can move that seamlessly. The second piece of EdgeConnect is what we call WAN hardening. One of the things you want to be able to do with a device like EdgeConnect is plug directly into the Internet. If you order Comcast cable Internet, you want to be able to take that Ethernet port from their modem and plug it straight into the EdgeConnect device. That means that the device has to be hardened and be able to support direct deployment on the Internet. Often we would be deployed with a router, in terms like with an MPLS router, and many times we're also deploying direct from the Internet, so we want to be hardened. We want to make sure that traffic is secured all the way from edge to edge, and so we build our overlay with 256-bit AES encrypted IPsec tunnels. The other thing you want to be able to do is path conditioning. So path conditioning is a bucket into which there's many individual features. The most important thing that we have in path conditioning is probably our forward error correction technology. What this lets you do is ride over periods of loss or brownouts in the Internet or broadband services. It works by, when you send data, we send not just the original packets, but also error correcting packets. And when those packets reach the far side of the network, if any of the original packets are missing, we can use the packets we got plus the error correcting packets to, on the fly, reconstruct the missing packets without needing to retransmit anything. And so from the outside of the EdgeConnect system, from the user's point of view, it looks like they have a very clean, pristine network, even though on the inside there is packet loss, packet reordering, and other things going on. So we call that path conditioning. It makes any one path perform as best as it possibly can. And you can think of the path control as in selecting between the paths. The last piece about EdgeConnect is cloud intelligence. And so a big part of being, as we mentioned, of being able to build a WAN that leverages the Internet is being able to drill down and understand the different categories of Internet traffic. And to do that, to know that this traffic's Facebook or that this traffic is going to Salesforce North America Data Center 3, we need to have intelligence, and that intelligence needs to be continually updated because things change. It's not static. It's not like the old IETF assignment of well-known ports in UDP and TCP, where those things were done and they stayed the same for several years, and so you could embed that in your software. In an Internet world, the cloud changes quickly, and so the application classification intelligence needs to be something that is updated. And Cloud Intelligence provides essentially a real-time feed to assist in application classification. From the orchestrator point of view, there are several important pieces. One, we let you do single screen administration, so that from that one place you can set your policies in a single form very, very simply and roll it out to the network. It lets you monitor and report on both the applications that the users are using as well as the state of the network, so you can determine for a given path through a given provider how they're performing and use that to open trouble tickets or resolve issues. The last piece we provide is bandwidth savings reports, so that there's a way of justifying your purchase and understanding how much you've saved. Finally, there's the boost piece, which we've talked about. The boost is application acceleration on demand. It brings latency mitigation and data reduction encompassing compression and deduplication to the table and lets you buy it by the megabit per second and apply it when and where it's needed. So when you bring this all together, what do you get? First of all, you get flexibility. You get flexibility to build a wide area network that augments or replaces MPLS with the mix of broadband connectivity that makes sense for you. So you can use cable in some places, DSL in other places, 4G LTE wireless in other situations. It also brings you the flexibility to deploy with a virtual or a physical form factor. The second thing you get is you get visibility and control. You get the ability to understand your Internet traffic at a much more granular level, understanding what the service is, understanding the geolocation, geography information. Where's this traffic going to? It enables you to keep your traffic encrypted edge to edge, and so that you know that regardless of whether the traffic's going over an MPLS route or over an Internet route, it's secure all the way from one edge to the other. The third thing you get is performance. You get the base performance with Edge Connect, leveraging path selection and path conditioning. The boost gives you an extra level of performance for those applications that need it. And then finally, the fourth piece of value is around savings. So you get savings from being able to leverage cheaper broadband bandwidth. You also get savings from OpEx. Basically, this is an easier WAN to manage. You do not need so much expertise to deploy and manage a 400 or 4,000 branch network. There's no need to understand all about OSPF and BGP to get this network up and running. The third part of savings comes from CapEx. And as you kind of look forwards a little bit further down the path, there you can see a thin branch where in that branch all you have is an Edge Connect device and your Wi-Fi access points. And as a step today, you deploy with a router, but eventually for some branches we see Edge Connect may be all you need. You won't need a firewall or a router in that branch. And so in that way, over the longer term, you get CapEx savings. As a customer example, we have a customer called Group Deco who is a LED lighting specialist, and they have used Silver Peak to move to broadband and save a bunch of money. They've more than doubled their WAN capacity at the same time as reducing their bill to a fraction of what it was. As Ethan mentioned, this is not a technology where you have to make an all or nothing bet and replace everything in your WAN all at once. You can deploy Silver Peak's SD-WAN technology incrementally. So you can do it in two ways. One is you can augment your MPLS network. So you can add broadband connectivity into a select number of branches and get up and running that way. You can also say, I've got 10 new branches I'm adding next year, and for those branches, I'm going to go with pure broadband connectivity. I'm going to subscribe to 2 broadband services and use Silver Peak to bring up those 10 branches. And so the important thing is to realize there's easy ways to start. You can start today. You don't need to make a huge capital investment and rip and replace everything in your network all at once. So that brings us to the end of the plan presentation, and we have a few minutes for Q&A.
Yeah, thanks, David, and thanks, Ethan. We are pushing the top of the hour, so we're going to have time for one, possibly 2 questions that have come in, and I'll get to that in 1 second, especially the question that has come up a few times. For the rest of the folks on the call, please continue to submit your questions via the Q&A widget, and I'll remind you again that the presentation will be available on demand and will be emailed to you within the next 24 to 48 hours. So if you are not able to get your questions, feel free to email us at questions@silver-peak.com, and we'll reach out to you afterwards. So with that, let me throw out the first question that's come out. It's come out a couple times, and that is the overlay a necessary piece of an SD-WAN, and if so, why? Why don't we start with Ethan and then David jump in.
Is it necessary? It is the part of the solution that makes it that you can deploy it on demand without it being an all or nothing piece. Do you have to have it? There's only one solution out there that I know of that isn't using an overlay in some way. Remember that one of the big pieces that you're getting with the overlay is the security element. If you're not, another via the encryption, via IPsec, via robust key management and all of that stuff that you're not getting if you're not actually leveraging an overlay. So do you have to? Well, you don't technically have to in all scenarios, but I think it's the strongest fit. It makes the most sense.
Yeah, I would agree that the overlay is what brings a lot of the advantages. So technically, whether you could build an SD-WAN without one is probably a separate question. But where does a lot of the value come? A lot of the value comes from the fact you're using the overlay. The overlay, as Ethan mentioned, lets you get the end-to-end encryption. It also is a much easier way of doing path selection. So it's so much easier to select the best path when you're making measurements from end to end of parallel paths. And when you're making those measurements not based on samples, say from a ping, but by actual data in the packet. So in the Silver Peak's case, every packet has a sequence number, every packet has a timestamp. And so for every packet, we're measuring the actual loss and the actual jitter and actual delay on each path and making a decision based on that. And I don't think you can do that kind of thing without an overlay. And I think that's why when you look out there at the market, almost all of the solutions utilize an overlay.
Great. Okay, guys. Thanks, guys. With that, we're actually out of time. So it's time for us to wrap up. For those of you who have not had your questions answered, we have a number of those. We will follow up with you via email and respond to your questions. On behalf of Silver Peak, we want to thank our speakers, Ethan Banks and David Hughes, and thank all of you for attending today's webinar presentation entitled Evolve Your WAN with Broadband. As I mentioned previously, you can download today's slide deck via resources widget at the bottom of the screen. The on-demand presentation will be sent out within the next 24 to 48 hours. Thank you again, everyone, for attending, and have a wonderful rest of the day.